Off was.
I got a question.
Oh no. What?
This problem right here we had.
Read it to me.
A to the O.
A to the 0.
Okay, B to the -4.
B to the -4.
Okay. Over A to the -3. B.
Okay. Separate it. Treat it as two separate problems. All right, problem number 1.
Sorry, it's sharper on one side. It's still sharper on one side.
Oh, no, it's not set on standard. Oh, yours is. Never mind, yours is a fat pencil. You're late. She smiles about it. Oh, yes, I am. But it's 8 o'clock in the morning. So as you separate into two problems, you simplify both sides. Now, there's two choices. You can replace A to the 0 with just plain old 1. Or you can use the rule which says a base over a base, you take the exponents and you subtract them. So it's 0 minus a -3.
-3.
What's 0 minus a -3?
Oh, +3.
Positive 3. So this will become A to the 3rd. Now here you got B to the -4th over B to the 1st. Subtract them, you get -4 minus 1, which is -3. Negative what? -5. -4
Oh, yeah.
minus 1. Not minus 1, just minus 1. So this becomes B to the -5. Well, you can't leave negative exponents, so now what can you do?
A to the 3rd over B to the 5th.
Yeah, drag that B to the
Yeah, go
5
down to
down.
the bottom. Yeah.
So A to the 3rd, B to the 5th. If you get confused with the exponents, I used to do this all the time. Go off to the side and do the subtraction so you can see what it looks like. Because sometimes you read it in your head and seeing it on paper, they're two different things. Paper will always be usually correct. Always usually be correct. That's a contradiction statement. Any other major questions? Well, 5, right?
That up my foot. In the lunchroom. Thank you.
All right, emergency pencil. So we left off with, we did base times base. We did base divided by base. We did the base raised to the 0 power. We did the base raised to the negative exponent and moving it up and down in a fraction. So the only two rules left, we were only on rule 2 if I remember right. And rule 2 had part A and part B associated with it.
Yeah.
So this would be rule 3. A to the m, b to the n, raised to the p. Well, actually, no. That's going one step too far. A to the m raised to the p. Let's go simplistic first, and then we'll build into the harder one. Now, when you read this in exponential language, it reads as there are p factors of a to the m. You know, a to the m times a to the m times a to the m, and there'll be p of them. But the inside says that there are already m factors of a. So then you have these m factors of a times another m factors of a times another m factors of a. So if I just read it in longhand, there are p factors of m factors of a. What operation do you think happens when I say p factors of n factors? Multiplication. That's a multiplication because it's like 5 plus 5, or 5 times 5 times 5 times 5. No, that wouldn't explain it. Hold on. 5 plus 5 plus 5 plus 5. So this becomes a to the mp. This is the one you need to memorize. This is the one that'll tell you when to multiply and when to add. Because if you cannot say a power to a power, more than likely you should add the exponents. Because most people, when they get confused at this point. They're like, is this a to the 6th or is this a to the 5th? And if it's not a power to a power, the only thing you can do to these exponents is Atom. So this is the one you memorize so you don't screw up this one over here, the a squared a cubed. So power to a power. You multiply. Exponents. Multiply those exponents. Okay. This, of course, has its own little sub-rules. Sub-rule A was the one I was trying to write up there. A to the m, let's keep it simple. AB raised to the m power. Let's keep it simple. AB raised to the m power. Well, this is n factors of AB. So how many A's are there? M of them. How many B's are there? M of them. So this is going to become A to the M, B to the M. You have m factors of A and you have m factors of B. All right, increase the difficulty a little bit. A to the M, B to the N, raised to the P.
A to P, B to P.
Yeah. You're going to have P factors of M factors of A, so that's AMP from this rule up here. Kind of mixing these two rules together. And the next one would be BMP. What property does this look like it's performing? It looks like the distributive property, but don't get confused. It really isn't. It is not the distributive property. It just looks like it is. Distributive property has nothing to do with powers. This is just saying that if you have a P on the outside, it affects every little piece on the inside. So for instance, if you have -2 a third b -2 raised to the 4th power, that 4th power on the outside is affecting everything on the inside. So you can kind of break this down into -2 raised to the 4th. The -2 gets its own little power. Notice I have to keep it inside of parentheses because it was inside of parentheses to begin with. Then you get a cubed raised to the 4th. That gets inside its own little parentheses, so you get a cubed raised to the 4th. And then b to the -2 also raised to the 4th. So each little product on the inside is getting its own little power. What operation is on the inside? It's all multiplication, no addition, no subtraction. So if there's a plus or a minus in there, this doesn't work at all. And I'll show you an example of that. What's -2 to the 4th power?
16.
Positive or negative?
Positive.
Positive. So this is 16. A cubed to the 4th.
A to the 12.
Power to a power you multiply, so you get a to the 12. B to the -2 raised to the 4th.
16.
No, b to the -8th. Because it would be -2 times 4. You're going -2 raised to the 4th. -2 times 4. So this is b to the negative, no, I was about to write 16. 8.
So it keeps us negative no matter what?
Yeah, I mean, it's -2 times 4.
Oh, that's right. Okay.
I mean, it's going to be a
I'm
-8.
still thinking.
All right, what should happen to that -8? Goes to the bottom. I'll write the answer over here. I'm going to have to move it down. So the answer is 16a to the 12 over b to the 8th. And there you are. Now, if you do this process one step at a time, generally most people don't make mistakes. It's the ones that do it in their head and don't show any work on their paper that will really, it'll kill them. Because there's so many little things going on here that it's easy enough to lose pieces
Paper
of your
smoke
head.
like smoke. You can tell I did the work.
Hopefully on the test I'll be able to tell you to do work. All right. Rule 3 also has a part B to it, and it looks something like this. A over B raised to the m power. It's actually the exact same rule as part A. This is just a times b raised to the m power, and the a got an m and the b got an m. So here, if you think about it, it is m factors of the fraction ab. Now yesterday, most of you, when you saw like -1/4 squared, you wrote -1/4 times -1/4, which is fine, that'll work. But this might be a little bit easier to handle. The top gets a power of m, and the bottom also gets a power of m. You can separate the power top and bottom. That way, if you have like 1/4, 1 to the 17th is still 1. And then you can just ignore that part and concentrate on the denominator. Of course, this one also follows if they both have powers, you just raise everybody to the same power. Power to a power multiply. So rule number 4, the book writes it a little different. I'm going to write it this way. Now, anybody that had questions about negative exponents yesterday, I was very careful with my language with it. It is called the reciprocal power for a reason. What does the reciprocal mean? You take a fraction and you flip it. Why is this one flipped? Well, it takes this last rule. It applies the -1 to the a and the b, so it becomes a to the -1 over b to the -1. But then the a and the b are on the wrong side, so it flips. So this just becomes b over a. That's probably the most useful rule when things are raised to negative exponents. You allow yourself to get rid of the negative by just taking the fraction and flipping it. I can't think of any other rules. Let's do just a couple examples out of the book. Make sure we know what we're doing. Be able to reproduce it. Lab on Tuesday. Should we have a quiz on Monday? Well, we have school on Monday. So, let's see, let's find a horrible one. Oh, here's a horrible one. 46. Page 34. Page 34. Number 46 has 3x to the -4y over x to the -3 y squared, all raised to the -2. All right. Now remember, there is no order to these laws of exponents. There is no order. So what you want to do is the step that makes it easiest for you. I might be doing mine slightly different than yours, but I've been doing this a long time, so I know what makes it a lot easier for me, not necessarily for you. So there's two possibilities that we can start with right now. We can either deal with the outside or we can deal with the inside. Which one do you want to deal with? Inside. That's my preference. Simplify the inside. Make the inside smaller, then worry about the exponent on the outside. All right, so if I separate this and ignore that -2 just for a second, we're going to get 3 over 1, x to the -4 over x to the -3, y over y squared. And of course, I'll put it out there, but it's way out there, that -2. We're not touching that part though. So this is actually a mental step. This is something that I would expect you to be able to do in your head. This part, separating them out and seeing what their individual answers are. But I like writing it down for now. So here, 3 over 1, is there anything I can do with it? Nah, just leave it alone. 3 over 1. X to the -4 over x to the -3. What is it?
Flip them.
You can, but even then you still have to simplify it, so I would rather just go for a law. What's x to the -4 over x to the -3? What do you do with the exponents when they're above each other? Subtract them. What is -4 minus a -3?
-1.
-1. And when you write it, it literally is x to the -1 over 1. I'm writing all as fractions just in case I have to move things up and down. What's y over y squared?
2.
Remember, this has an exponent of 1. So it's going to be 1 minus 2.
1. Oh, -1.
-1. So you're going to get y to the -1. That answer goes up top. And of course, this whole thing is raised to the -2. I'm making it long and drawn out, but eventually you're going to come up with shortcuts to simplify it. That's perfectly fine. All right, what should I do with the x to the -1 and the y to the -1? Should I leave them where they are?
They're negative.
Throw them down.
Go down, yeah.
And once I put them down, I can combine this as one fraction. It'll be 3 on the top and xy in the bottom. So it's going to be 3 over xy. And this whole thing is being raised to the negative 2. Now see what happened. From the beginning, this thing was big and ugly on the inside, really complex, x's and y's all over the place. But after we simplify it, it's one number, 1x, 1y. That's the way it should look. That way you don't have so many pieces floating around. Now, on the outside exponent, what's that? What? What'd you say? I'm just curious.
It's gonna be 9 over xy.
No, it is not. You forgot one little piece.
Negative.
No, good God, no. What does this negative do to a fraction? Come back over here. What does a negative exponent do to a fraction?
Oh, flip it.
It
Okay.
flips it.
Okay.
So to get rid of this negative exponent, which are usually very confusing, take this entire fraction and
Flip it.
flip it. So you're gonna get
xy over 9.
xy over 3 squared. Don't jump steps. You will make mistakes. Now, what happens with everything on the inside with that square on the outside? They get squared. So the final answer is x squared, y squared over 9. You kept getting the 9 right, but then you forgot the square on the x and the y. Yeah. Each and everything on the inside has to be squared. Now, do I expect you to show all of those steps? Only if you start getting wrong answers should you show all of those steps to see what each piece is doing as you go down. But personally, I think you can get away with jumping from the first step to the third one here, and jumping, and then everything else afterward, I would highly suggest you show. So the first step you should show. The second step you don't have to show in this way, maybe just as a single fraction. Definitely show this step, and finally the last step. Make sure you see all that's going on. Alright, how about 48 looks cool. X cubed, y to the negative 2, all raised to the negative 2, 5x to the negative 5th, all raised to the positive 2. Right. Can you multiply x cubed and x to the negative 5th?
Yes.
Yeah.
Of this negative,
Order of operations, what has to happen first?
everything is in the present.
Exponents. You cannot touch anything on the inside here until you deal with the exponent that's on the outside. So once you see exponents up high around parentheses and a bunch of stuff on the inside, you can't do anything with the inside until you deal with the exponent. So before I can do anything with anything on the inside here, I got to deal with this negative 2. But again, I might want to simplify the inside. How can I simplify x cubed y to the negative 2?
You multiply.
How do I simplify it? That y to the negative 2 is just, ugh. Where does it belong?
On the
On
bottom.
the bottom.
On the bottom. So rewrite this as x cubed y squared raised to the negative 2. All right, the second one, how would you write it?
1 over 5x.
No.
5 over x.
This 5 has nothing to do with
Oh, so
that
it'd be
negative
5
5
over x
exponent. So it'd be 5 over x to the 5th. You only drag the base down. You don't touch anything else. And this is raised to the second power. Okay. And that way things start looking nicer a little bit. What does this negative on this 2 on the first one do to the fraction?
Negative.
No, it doesn't. Will you stop that?
What you say?
What's it do? It takes a fraction and flips it.
Yeah.
So y squared goes to the top and x cubed goes to the bottom. And the exponent is going to change to a positive. So instead of negative 2, now it is positive 2. And then leave the other one alone. 5x to the 5th raised to the 2nd. Okay. Now we've gotten rid of every single negative exponent going, which is really good because negative exponents are just funny things to begin with. And then it's simple after this. Y squared squared. Y to the 4th, base to the base, power to a power, multiply. X cubed squared, x to the 6th. And then over here, 5 squared, 25. X to the 5th squared, x to the 10th. Now I have the product of two fractions. How do I deal with the product of two fractions? Straight across. So y to the 4th times 25, better known as 25y to the 4th, over x to the 6th times x to the 10th. 16, because you add the exponents. And there's your final answer. It's not that bad. It's just you have to be very focused on rules. Everything is a rule in this case. I don't think they get any worse than that. All right, so for homework for section 1.4, I'm not done for the day. I'm just telling you what the homework for section 1.4 is. Finish all the practice problems all the way to 17. Even though I didn't teach you scientific notation, you should be able to figure it out. It's not that hard. If you have problems with it, you can ask next class. It's not a big deal. All the way, practice problems, they start at 10 and you go to 17. If you haven't done the first ones, now you have 1 through 17 to do. On page 34, you've already done up to number 35, if I remember right. Yeah. So start on 37 and work your way through 63, odd. 37 through 63 odd. Be able to get the right answer. This is really important.
What page you got?
The exercises are on page 34.
Okay.
And you start on 37 to 63 odd.
Okay.
Check the back of the book. Make sure you're getting the right answers, exact as they have them. This is a very precise rule setup. Now, one place where people make mistakes with this rule, and I see it all the time, is this problem. X plus y all squared. A lot of people will write it as x squared plus y squared, thinking it's following one of the laws of exponents. But if you're going to follow the law of exponents, this is two factors of x plus y, and it literally is x plus y times x plus y. And when you get to polynomials and multiplying, what takes over? Oh, distributive property. So you get x squared, you get xy, you get yx, and you get y squared. So this is really x squared plus 2xy plus y squared. Sure, it has the x squared part and it has the y squared part, but it also has that little middle piece. So be really careful. The laws of exponents do not work on pluses and minuses. It is not the distributive property. It is not the distributive property. So make sure you get this in your head. X plus y squared is not equal to x squared plus y squared. Guaranteed without a doubt. Does not work over addition. But a lot of people do it. A lot of people do it. Okay. So now we're going to move on into 2-1. Easy land for most of you. But I'm going to be really picky about it, so be careful. 2-1 is just linear equations. Linear equations are the start of algebra, not the end at all. Linear equations just happen to be the nice, easy first step. So this will be 2-1. Plenty of time. What do they call it? First degree equations with one unknown. First degree equations. We'll talk about that in a second. Why are they getting fancy with the title instead of just calling it a linear equation? Well, linear equations, there's many different types of them, and they're just being really, really specific about it. When they're talking about a first degree, this word right here is always talking about the exponent on the variable. So if your variable has, x plus 5 is equal to 7, this is called a first degree equation because the exponent on the x is 1. Now, if you have an equation that's x squared plus 5 is equal to 7, which eventually we will be solving. This is not a first degree equation in one variable, this is a second degree. Because the exponent on the x is 2. And so forth and so on. So when we're dealing with first degree equations, that first labels the exponent on the variable to be 1. Now this one unknown, this one actually is first degree, one unknown. Oops. Exactly the way I'm looking for it. If I write it this way, this is still a linear equation. It's still a first degree linear equation. So that's perfectly fine. What's wrong with it?
There's 2 unknowns.
There's 2 unknowns, and that's our problem. This one has 2 unknowns. We'll be dealing with those again later. So this first section, real solid section that we're going to actually have a test on. It's a very short test. You know, you've got 1, 4, 2, 1, 2, 1, 2, 2, 2, 4, 2, 6, 2, 6. So the first chapter is going to be really, really quick, really, really fast. Let's see how you do on it. So this one is just going to be working with real simple equations. Do you think I'm going to put this one on the test?
No.
Heck no. If you don't know how to solve this one, I'm really worried. But I am going to go through the process of how to solve an equation. And I'm very precise about it because I know what kind of equations are going to be coming. You pretty much are pretty safe with simple ones like this. I'm going to make them a little bit, nastier. So when you're solving an equation, there's a few rules that apply. One of them is rules of equality. These are kind of like, commutative, associative, distributive, those type of rules. They're the basis of our mathematical abilities. Rule number 1 pretty much says this. If you have x is equal to 5, I just tell you x is equal to 5, that's perfectly safe. Then they're equal to each other. That means wherever you see an x, you can replace it with. And actually, if wherever you see a 5, you can replace it with x. It really doesn't matter, but most people go left to right. What I can do is add equal amounts on both sides. Here I just chose 7. Does it help me do anything? No, but I'm trying to illustrate a property. One of the rules is what's called the equality, addition, additive, get the words right, property of equality. If you take any number and add that number to 2 sides of an equation, the equality stays equal. I know that's redundant, but you're not changing the value on either side. X plus 7 is the same thing as 5 plus 7. So now you have x plus 7 is equal to 12, and that's perfectly fine. All right, if I have x is equal to 5, go back to my little example here, and I choose to multiply both sides by 3. That does not change equality. Now I just have 3x is equal to 15, and that's perfectly safe. This has its own little rule. This is called the multiplicative. I'm not going to write out the whole word. Property of equality. Now you have to be really, really careful with these properties. When you apply them, they're applied to an entire left-hand side and an entire right-hand side. For instance, if I go back up here and I write, x plus 7 is equal to 12. And then I apply what I did in the second one, which is multiply both sides by 3. When you multiply both sides, it can't just be the x that gets it. The 7 also has to buy into it. So you have to multiply the entire side by 3. You have to. That's just the multiplicative property of equality. Now, additive property of equality says you can add the same number to both sides. Did I say the number had to be positive? No. So you can also subtract. That'll work perfectly fine. So subtract is already built into this one. You're just adding a negative number. Do I have to multiply both sides by the same thing? Or can I use division? I can divide. And the process there is, instead of multiplying by 3, I could have multiplied by 1/3, which is the same thing as dividing by 3. So division also works over here. But the same thing has to happen. If you use division, it has to affect an entire side, not just a piece of the side, all the terms of it. All right, so those are the basic rules of equality for linear equations. And it pretty much works down to whatever you do to the left, you have to do the exact same thing to the right. And that pretty much works with all types of equations. Okay, so let me go through my steps. They don't do this in the book, and I don't think they do this in the book. Oh, actually they do. Okay. They have it. It's on page 60. I'm not sure if they do the exact same way I do it. You could tell me later if mine is the same as theirs. Number 1. Get rid of parentheses. Any parentheses that are lying around, you get rid of them. How do you get rid of parentheses in math?
Solve it inside.
What property comes into play, though, to get rid of parentheses? Distributive property. That's the only one that had parentheses on one side of it and none on the other. So this will always be distributive property. You're going to get rid of all the parentheses so you can move pieces around. Parentheses usually lock things in place and you can't move them. If you get rid of the parentheses, things are free to move around, which is exactly what you want. 2, move by properties of equalities. Variables. Oh, shoot. Why am I making silly mistakes? Not yet. A lot of people think that's the second step, moving the variables around. But after you remove parentheses, your step right after that should be simplify. Combine like terms. Combine like terms. Because when you get rid of parentheses, you're expanding something out, and sometimes you can put pieces back together. And that's a very critical step, because if you leave a lot of pieces lying around, people make some weird mistakes. So if you put them all together, it gets them into one location, and then you can start moving things around nicely. So step 3, move variables to one side. What side do most people choose? Left. Do you have to go to the left, though? No, you can move them to the right if things become easier that way. Now, when we get to section 2, this step is going to change just a little bit. The wording of it's going to change just a slight bit. 4, move numbers that are not associated with variables to opposite side. So if you move the variables to the left, move all the junky numbers to the right. If you move the variables to the right, move all the numbers to the left. Just go opposite side of it. And then finally, I'm going to call it isolate and solve for variable. Now I'm curious what they said. Oh, I didn't deal with the fractions, but we'll get to that. Combine like terms if possible. Yes, I got that. Got the variable on the same side. Add or subtract the other terms on the side. They say divide each side by the coefficient of the variable. That's the step that gets a little wishy-washy sometimes, so we'll talk about that. That's why I like the word isolate rather than just divide that coefficient across. And then solve for the variable. It's usually by division, but it doesn't have to be. It doesn't have to be division. It could be multiplication. Okay. So let's do a simple equation and then build in one extra step in there for those fractions. Simple equation. I have no idea what the answer is, since I just made it up off the top of my head, which makes it interesting. So if we're going to follow the steps that we have here, the simplified 5 quick steps of solving an equation, no fractions intended, what would you do first? Get rid of the parentheses. Now, I've had people do 4 minus 3 is 1, and you can't do that because the order of operations says multiplication definitely has to happen first. So you're going to take this 3, but don't forget the sign that's in front of it. This is going to be a negative 3 times everything on the inside. And as you start working, you know you're not going to touch the 4, so just leave it alone. Write it down. You're going to be like a typewriter. You always go to the left and write all the way to the right. I hate people that do the steps in the middle and then they lose like
That's
get out of here.
I think Mr. Miyagi.
We do it with chopsticks. I've had people leave the 4 up here, do the distributive property here, do the distributive property there, and leave the 12 up high, and eventually they lose the 4 or the 12. Make sure you write the entire problem over again. I know it seems like a lot of writing, but it does keep things together. So here you're going to get negative 3 times x is? Nobody makes that mistake. This is the one that I worry about. Negative 3 times positive 2? Negative 6 is equal to, that one's easy, and this one's easy, and then plus 12. Now you could, skip over step 2 and jump right into step 3, but it does cause a lot of, you're not quite sure about things. Like for instance, I have seen people add 6 here, underneath the negative 6, and add 6 over here underneath the positive 4. Because they think they're moving the number. They think they're moving it, but they're both on the left-hand side. So it's better just to say, well, what's 4 minus 6?
Negative 2.
Negative 2. So this is negative 3x minus 2 equals. When you're on one side of an equation, it's really an expression. You're not trying to solve for something over there. You're just trying to simplify. On this side, the numbers are next to each. Oh, by the way, what property allows me to add the 4 and the negative 6 like that? Identity? Yes or no? No. Inverse? No. Commutative? Yes, because we change the order of things. We move this 4 and the 6 next to each other. So whenever you're adding over things, that's a commutative property. Here we don't need to commute, they're right next to each other. 8x plus 4. All right, so that's step 2, simplifying your expression. So step 1, get rid of the parentheses. Step 2, simplify your expression. All right, step 3, get the variables on the same side. Now, you have a choice. Do you want to move the 8x to the left, or do you want to move the 3x to the right? Most people want to say the 8x. You don't want to know why I don't want to move the 8x? It'll make it negative. And negatives sometimes cause people, I don't know what they do with them, but they do some weird things. So. But I'll do it. I'll move the 8x. So how do I move the 8x over here?
Divide.
You do not divide. To move the 8x, you want to make a 0 here. And the only way to make a 0 is its additive inverse, which is negative 8x. So if I subtract 8x on the right, I need to subtract 8x on the left. I know some people have had teachers that would write negative 8x here and negative 8x. I find that messy. I'd rather do it right underneath it to see what's going on. What's negative 3x minus 8x? Negative 11x. So this is negative 11x. Minus 2 is equal to 8x minus 8x. 0. Don't say they cancel. It actually turns into 0. Then 0 plus 4 is 4. Now what properties did I just use?
Addition.
Nope. Inverse property of addition. And then this turns into 0. And then 0 plus 4 is identity. And you get down to 4. So when you say cancel, it means a lot of different things, and you have to be really careful of it. There's that canceling of addition, which is usually additive inverse and additive identity mixed together in one step. And if you're doing division, it's usually multiplicative inverse and multiplicative identity. That's just a shorthand language when you say cancel. You just realize it's inverse identity mixed up together. All right, and then the third step, or fourth step, I'm sorry, move the numbers to the opposite side. Well, what number do I want to move? The -2. So you say, well, I want to get rid of it, so it's going to be the additive inverse here, which would be +2. And then if you do it to the left-hand side, make sure you do it to the right-hand side. Do you see what's not moving on my equation? Mm-mm. The equal sign. My equal signs will always line up, so I can tell right away what side is the left-hand side and what side is the right-hand side. Don't justify your work, left-hand column, because that moves the equal sign in a diagonal pattern. All right, and then finally, we're down to -11 x. -2 plus 2 is 0. 0 plus -11x is -11x is equal to 6. Now we get down to the step that I want to say, don't use the word divide, but I'll let you use it. You can either multiply both sides by the multiplicative inverse of -11, which is 1 over -11, or -1/11. But here, you can also just divide. So divide both sides by -11. Okay. -11 divided by -11? 1. 1 times x is x. Remember, it's that mixture of inverse and identity that gives you just plain old x. And then on the other side, of course, is -6/11. Now, out of all of this, which steps should you show? Well, if you find you're making a lot of mistakes, I would show every single one of these. The one step I always show is this division. You want to know why? I have to show this. I have to see what's going on. Because I have seen people do this. Is that right?
Yes.
No.
No, I'm not.
Oh,
I do.
you do that? I have to show the step because I think of it as, oh, there's an 8, there's a 4, that's only 2 off, so I write 2. But actually, when you divide by 8, the answer really should be 1/2. So personally, I show the division part. If you have problems with signs, adding-wise, I would show this step. Show the adding the 2, show the subtracting the 8x, making sure your pieces are going the right way. So if you get the right answer consistently, you can skip all the steps if you want and just, move the pieces and show the main green lines up here and not the blue ones. But if you start finding you're making sign mistakes or you're getting your answers reciprocal style, start showing all the work. So it really is up to you to decide which one you want to do. Plus, if you show me all the work on the test, partial credit. If you show me an answer, right or wrong, it's up to you. The freedom of education. So what happens if I throw a fraction in there? It gets harder. It adds one more step to the process, but it's a simple step. And it depends on where the fraction is, how you're going to handle it. It gets harder. I only got 5 minutes, so I can only show you one problem. Oh, 2 problems. I'll make one easy. I'll make one easy. 1/3 x minus 1/5 is equal to 3/2 x plus 3/10. Okay. Now you're saying to yourself, oh, I don't like working with fractions. I hate common denominators and dividing by fractions and all that fun stuff. Well, in an expression, you cannot avoid that. If it was just an expression and I wanted you to simplify it, you'd have to work with common denominators. You'd have to work with dividing by fractions and all that mess. But if it's an equation, there's a neat little shortcut. Because I can multiply anything I want on the left and anything I want on the right as long as they're exactly the same. So I get to choose a number. Now, what number am I going to choose? Well, I'm going to choose a number that has a factor of 3, a factor of 5, and a factor of 2. Now, once I put the 5 and 2 together, what do I get? 10. So what number is 3 times 5 times 2? 30. So if I multiply both sides by 30, what's going to happen is the denominators are going to go away. Because this 30 will have each one of those as a factor, a multiple. All right, so I'm going to take this entire side, and I'm going to multiply it by 30. It has to be an entire side. How many pieces are inside those red parentheses? 2. So it's going to get multiplied twice. Even if it's not a fraction, it still has to get that 30. And then over here, I'm going to multiply through by 30. There's another way of writing it, and I prefer it for some people, writing the 30 by each and every single term. It like distributes over the entire equation. All right, so what's 30 times 1/3 x? What's 30 times 1/3 x? 10x. Basically, it works this way. 3 goes into 30. 10 times 1 is 10. So you get 10x. Minus, what's 30 times 1/5? 6. 5 goes into 30. 6 times 1 is 6. Over here, what's 30 times this 3/2? Well, 2 goes into 30. 15. 15 times 3. 45. So this would be 45x. Don't forget the x. And then 30 times 3/10. Well, 10 goes into 30. 3 times 3 is 9. It's a neat way to deal with multiplying by a fraction. Divide up and multiply over. Now we're down to a regular old setup. So once you get rid of the fractions, it should look like a nice linear, no fractions at all type of equation. What would you move next?
6.
No, I would not touch the 6 and the 9. You worry about the variable first. Numbers are pointless. The variables are the more important part. So which one would you move, the 10 or the 45? I would move the 10. So this becomes -6 is equal to 10 less than 45. 35. So you get 35x plus 9. Now you can move the 9. Because you want to get it away from the x. You're trying to get the x by itself, isolated. So you're going to subtract 9 from both sides. And this becomes -15. Again, if you do make that sign mistake, show your work underneath. It's not a big problem. It's actually a better thing. I'd rather you do it that way. And then this side becomes 35x. Then, finally, divide by 35. Now, I'm going to put my x on the left-hand side. If you have an equation, you can just flip it over. That's not a big deal. One way and the other, they're exactly the same. It's called the reflexive property of equality. So if I divide by 35, I'm going to get -15 divided by 35. By the way, if you type that into the computer, it'll mark it wrong. It's not simplified. It has to be simplified. Same thing for me. So 5 goes into both of them, so you're going to get -3 over 7. And there's your answer. -3/7. Do you want to check the answer? Can you check the answer? Yes. Do you want to? No. Same thing over here. -6/11. I would hate to put it up here and see if it actually worked. When it comes out fractions, most people don't want to check it. If it comes out a whole number, usually it's pretty easy to check.